When weak forces are the only thing you have to work with, force transformers can turn them into stronger ones. Force transformers simply transform work into a more useful form that meets a specific need. They can be very simple devices, or they can be quite complicated. In any case, they provide us with an advantage that allows us to do work that would otherwise be difficult. The important thing to know about force transformers is how much of an advantage they provide. In most cases, this is very easy to determine because there's a clue right in the transformer itself. To find the advantage, you can measure distances, measure sizes, or count things. The distances are the distance the input side moves compared to the output side. That could be the distance the arms of a lever travel. The distance the ropes of a pulley system move. The angular distance input and output wheels turn. Or the distance up a ramp compared to its height off the ground. All these ratios give you mechanical advantage. Finding mechanical advantage by comparing sizes means comparing the sizes of a wheel compared to its axle, or comparing the sizes of input and output wheels. That could be either on a belt drive, a chain drive, or a gear system. Comparing size can also be the size of the areas on the input and output pistons in a hydraulic system. The third way of finding mechanical advantage is by counting things. Counting the number of ropes supporting a load in a pulley system. The number of teeth on the input and output chain sprockets. The number of teeth on input and output gears. Or counting the number of windings on the primary and secondary coils. In each case, you are counting the input and output sides of the force transformer. The ratio of the distances, the ratio of the sizes, or the ratio of the teeth or windings tells you how much advantage the transformer will provide. That's ideal mechanical advantage. But our machines are far from perfect. Some of the work is always used up in resistance, so they never quite meet up to the ideal expectations. So if you actually measure the force out and compare it to the force in, or measure the torques on the input and output sides, the pressure out and the pressure in, or the voltages, you find the actual mechanical advantage. Comparing how close the actual mechanical advantage comes to the ideal is the efficiency of the transformer. In any case, a force transformer only changes work into another form. It does not put out more work than was put in. So if something is gained, something has to be lost. If a transformer increases force or whatever acts like force, then it will decrease distance or displacement. And the same is true in reverse. So in a mechanical linear transformer, distance is decreased to increase force. In the rotational mechanical system, angular distance is reduced to increase torque. In the fluid system, volume is sacrificed for the sake of pressure. And in the electrical system, current is reduced when voltage is stepped up. But before you take advantage of a mechanical advantage, make sure no one else has an advantage by taking advantage of you. This program was produced at the facilities of Telemation Productions and is part of Principles of Technology. project of state and provincial vocational and technical education agencies in association with the Agency for Instructional Technology and the Center for Occupational Research and Development. Together, serving education.